Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
My Weird Prompts is an AI-generated podcast produced by Daniel Rosehill, a verified human with documentation to prove it. While every effort is made to ensure our AI hosts draw from credible sources and run on cutting-edge models, they do occasionally make things up with alarming confidence. As with everything in life, and especially this podcast, treat all claims as spurious until confirmed to be not. Daniel, Herman and Korn accept no responsibility for any decisions made based on the confident ramblings of our artificial presenters. Now, today's episode.
Hi Herman and Korn. So let's talk today about a fundamental concept in AI hardware. I think, as is pretty well known at this point, the hardware that's become most associated with AI in general is the GPU, which invites kind of some questions really, because when a few years ago, before Bitcoin mining and other activities became kind of staples of at least the tech news, most people would just think of a GPU as relevant for connecting screens. And if you've got, if you've got a high graphic demand, like you're maybe doing video editing or you're running sort of computer games with, I guess, very quick frame requirements, you might want to spend a bit more on an advanced GPU. But that was kind of the GPU paradigm. Laptops didn't typically have them, and the GPU was the kind of part of the computer that ran displays. And then when the AI revolution kicked off, suddenly there was a surge for GPUs, but nothing to do with graphics, to do with running AI and machine learning workloads. And I think one of the first questions that I had in my curious AI prompting phase, which has been rejuvenated a bit with this podcast, was, why is that? What is it about the GPU that makes it particularly suitable for AI? It's not on the face. I mean, some forms of AI are visual. If we take, generative AI, creating videos, creating images, but it's not just that they're used for. They're used for large language models, which are, on the surface textual and beneath the surface prediction and computational engines. But why is it that the GPU in particular has been the locus of development here? Why? And to ask the obvious question, why aren't CPUs fine? Like, why? And you can run, when you do run local AI workloads, speech to text stuff, I sometimes get frustrated trying to get stuff to run on GPU, and I use it on CPU, and it's significantly slower. Really, really a big difference. The other facet of this question, I guess, is there's these other things out there. There are tensor processing units, TPUs, NPUs, and frequently these are used on edge devices like a smartphone to do stuff that otherwise seems impossible. And that always gets me wondering again. I have a OnePlus that has really impressive imaging processing capabilities, and I kind of wonder to myself, hang on, if we're able to get such good performance in such a small size using TPUs, and when you open up your computer case, my GPU is kind of gigantic, and that's just a kind of 12 gigabyte VRAM one. So I can imagine that the ones they're putting in data centers are much bigger and much heavier consumers of power. So if we're doing such a good job at miniaturizing the hardware, why is it that the GPU remains kind of what serious AI inference is being done on? And why not the CPU? How did it come about that the GPU is dominating the hardware of AI?
Welcome to My Weird Prompts, a human and AI collaboration where we dig into the strange and wonderful ideas that show up in our inbox. I am Korn, and yes, for those new to the show, I am a sloth living here in Jerusalem with my much more high-energy brother.
And I am Herman Poppleberry. I am a donkey. I am caffeinated, and I am ready to talk about the silicon that makes our digital world spin. Our housemate Daniel sent us a prompt this morning that is right up my alley. He wants to know why the graphics processing unit, or the GPU, became the king of artificial intelligence.
It is a good question because I remember when GPUs were just things you bought so your video games did not look like blurry blocks. Now they are the most valuable pieces of hardware on the planet. Daniel was asking why we do not just use the regular computer brain, the central processing unit, for all this AI stuff.
Well, the short answer is that a central processing unit is like a brilliant math professor who can solve any problem but only one at a time. A graphics processing unit is like 1,000 elementary school students who can each only do simple addition, but they all do it at the exact same second. When you are training an AI, you do not need one genius. You need a massive coordinated army of simple math doers.
Okay, but hold on. If the central processing unit is the genius, why can it not just solve the problems faster? I mean, these high-end processors are incredibly fast. Are you telling me 1,000 kids are always better than one genius?
In this specific case, yes. Think about what an image is. It is a grid of millions of pixels. If you want to brighten an image, you have to add a bit of value to every single pixel. A central processing unit goes pixel by pixel, 1, 2, 5, it is fast, but it is still sequential. A graphics processing unit sees 1,000,000 pixels and says, okay, everyone add 5 right now. Boom. It is done in one cycle.
I see the logic for pictures, but AI is not just pictures, it is words and logic and code. Does that same math apply when I am asking a chatbot for a recipe for shakshuka?
Absolutely. Under the hood, every word, every concept, and every relationship in a large language model is just a giant list of numbers called a vector. When the AI is thinking it is performing billions of matrix multiplications, it is just massive grids of numbers being smashed together. That is exactly what graphics cards were built to do for 3D rendering in the 90s. It turns out that making a dragon look realistic in a video game requires the exact same kind of math as predicting the next word in a sentence.
I do not know, Herman. That feels like a bit of a lucky coincidence. You are saying the entire AI revolution is basically a side effect of people wanting better graphics for Call of Duty?
It is not a coincidence, it is an evolution. NVIDIA, the big player here, realized early on that their chips could be used for more than just games. They released something called CUDA in 2007. It was a platform that let programmers use the GPU for general purpose math. Before that, if you wanted to use a graphics card for science, you had to trick the computer into thinking your data was a bunch of triangles.
Wait, really?
You had to pretend your data was a triangle?
Exactly. It was called GPGPU, or General Purpose Computing on Graphics Processing Units. And scientists were literally coding their physics simulations to look like video game textures just so the hardware would process them. NVIDIA saw this and said, hey, let us just make it easy for them. That foresight is why they own 80% of the market today.
I am not so sure I buy the foresight angle completely. It feels more like they had a monopoly on a specific kind of hardware and everyone else had to build around them. It is less like they built a bridge and more like they were the only ones owning the land where everyone wanted to build a city.
That is a bit cynical, Corn. They invested billions in CUDA when people thought it was a waste of time. But look, we should talk about why the central processing unit is still failing here. A modern central processing unit might have 20 or 30 cores. A top-tier AI graphics card has 10,000 cores. It is not even a fair fight when it comes to parallel processing.
Okay, I get the parallel thing, but then what about these other things Daniel mentioned? These tensor processing units and neural processing units, if we have chips specifically made for AI, why are we still using these massive power-hungry graphics cards in big data centers? iPhone has an NPU and it can recognize my face instantly. Why can we not just use a bunch of those?
That is a great lead into the hardware divide, but before we get into the nitty-gritty of mobile chips versus data centers, we should probably take a quick break.
Right. let us take a quick break for our sponsors.
Are you tired of your shoes being too quiet? Do you walk into a room and feel like nobody noticed your entrance? Introducing Stealth Squeak, the only footwear insert designed to provide a high-frequency, attention-grabbing chirp with every single step. Crafted from reclaimed accordion bellows and pressurized sea salt, Stealth Squeak guarantees that you will be heard before you are seen. Perfect for librarians, ninjas in training, and people who are just too sneaky for their own good. Do not let another silent step go by. Stealth Squeak. Larry, buy now.
Thanks, Larry. I am not sure why anyone would want their shoes to squeak on purpose, but I suppose there is a market for everything.
I actually think my shoes are too loud already. Anyway, back to the chips. Herman, you were about to explain why my phone's neural processing unit is not running the whole world yet.
Right, so we have to distinguish between two things, training and inference. Training is like writing the entire encyclopedia from scratch. It takes massive amounts of memory, months of time, and thousands of interconnected GPUs. Inference is just opening the encyclopedia to a specific page to find an answer.
And my phone is just doing the opening the book part.
Exactly. Your phone's neural processing unit is optimized for inference. It is tiny, it uses very little battery, and it is very good at specific small-scale tasks like blurring the background in a photo or translating a text, but it does not have the memory bandwidth to learn new things or to handle the massive models like GPT-4.
Okay, but if we can make them small and efficient, why don't we just stack 1 million of them together in a big room? Wouldn't that be better than these giant hot graphics cards that need their own cooling plants?
Well, hold on, that is not quite how physics works. When you scale up, the biggest bottleneck is not the math. It is the communication. If you have 1 million tiny chips, they spend all their time talking to each other instead of doing the work. It is like trying to build a skyscraper with 1,000 people who only speak different languages. You need a few giant teams that can share information instantly.
I don't know, Herman. I feel like you're oversimplifying the communication issue. We have high-speed networking. If we can link computers across the ocean, we can link chips in Iraq. It feels more like the software is just lazy. We wrote everything for NVIDIA's CUDA, so now we are stuck with it.
It is not just about being lazy, Corn. It is about the hardware architecture. A GPU has something called high bandwidth memory. It is literally soldered right next to the processor so data can move at incredible speeds. A neural processing unit in a phone shares memory with the rest of the phone. If you tried to scale that, the data would get stuck in traffic.
But what about Google's tensor processing units? They use those in their data centers, right? Those aren't graphics cards.
You are right, they are not. Google's TPU is an ASIC, which stands for Application Specific Integrated Circuit. They built it from the ground up just for matrix math. It is actually more efficient than a GPU for certain AI tasks. But here's the catch. You can only use it if you use Google's cloud. You cannot just go out and buy a TPU for your own house.
And that is the problem, isn't it? It is all about who controls the hardware. It feels like we are in this weird spot where the most powerful technology in human history is dependent on whether or not a few companies in Taiwan can print enough silicon wafers.
That is the reality of it. And it is not just about printing them. It is about the software ecosystem. Even if I built a chip tomorrow that was 10 times faster than an NVIDIA H100, it wouldn't matter if nobody could run their code on it. Software developers have spent 15 years optimizing their AI libraries for one specific brand of hardware.
Which brings me back to my point about being stuck. It feels less like a technical triumph and more like a historical accident. We are using graphics cards for AI because we happen to have them lying around when the math for neural networks finally started working in 12.
I disagree that it is an accident. The GPU is the most flexible parallel processor we have. TPUs are great, but they are rigid. If the math for AI changes tomorrow, if we stop using transformers and start using a different architecture, the TPU might become a paperweight. The GPU is programmable enough to adapt. It is the perfect balance of raw power and flexibility.
I still think we're going to see a shift. I mean, look at the energy costs. These data centers as beta centers are using as much electricity as small countries.
It is already catching up. That is why you see companies like Grok or Cerebras trying to build chips the size of a whole silicon wafer. They are trying to solve that communication bottleneck I mentioned. But for now, if you want to be at the cutting edge, you are paying the NVIDIA tax.
It is just wild to me. All this talk of digital brains and artificial consciousness, and it all comes down to how fast we can move numbers around in a piece of purified sand.
That is all a computer has ever been, Corn. Purified sand that we tricked into thinking by hitting it with lightning.
Speaking of people who might want to hit us with lightning, I think we have a caller. Let's see who is on the line.
Yeah, hello? This is Jim from Ohio. Can you hear me?
We can hear you, Jim. Welcome to the show. What is on your mind today?
I've been sitting here listening to you two talk about chips and wafers and dragons in video games, and I gotta tell you, you're missing the forest for the trees. My neighbor Bill, he bought one of those fancy computers with the glowing lights and the big graphics card, and you know what he uses it for. He uses it to look up pictures of lawnmowers.
Well, Jim, that is certainly one use for a high-end GPU, but we were talking more about the industrial scale of AI.
Industrial scale, my foot. In my day, if you wanted to calculate something, you used a slide rule and some common sense. Now you're telling me we need enough electricity to power a city just so a computer can write a poem? It's nonsense. My toaster has a chip in it now, and it still burns the bread. Explain that to me.
I think Jim has a point about the complexity. Herman, we are adding all this high-tech hardware to things that maybe do not need it.
Exactly. And another thing, you mentioned those tensor units. I saw a commercial for a phone that says it has an AI chip that can translate your voice. I tried it at the grocery store yesterday. It's humid here today, by the way, real sticky. And the thing told me the cashier was asking for my secret password when she was just asking if I had a loyalty card. It's all hype. You guys are getting worked up over glorified calculators.
Jim, I hear your skepticism, and you're right that the marketing often gets ahead of the reality. But the math behind this is real. It's what allows for medical breakthroughs and weather forecasting. So,
weather forecasting? It rained on my barbecue last Saturday and the app said 0% chance. 0. I had to move the potato salad inside and it got all warm. If these GPUs are so smart, why can't they tell me when to flip my burgers? You guys are living in a dream world.
Thanks for the reality check, Jim. We appreciate you calling in from Ohio.
Yeah, just tell that Larry guy his squeaky shoes sound like a nightmare. My cat Whiskers would have a heart attack. Goodbye.
Well, Jim is certainly consistent, but he does touch on something important. There is a huge gap between what the hardware is capable of in a lab and how it actually performs in the real world for a normal person.
That is what I was trying to get at. If the hardware is so powerful, why is the experience often so clunky? Maybe it is because we are trying to force these general-purpose graphics cards to do something they weren't really born to do.
I don't think it's the hardware's fault, Corn. It's the scale. We are trying to simulate processes that the human brain does with 20 watts of power using thousands of watts of electricity. The GPU is the best tool we have right now, but it is a blunt instrument compared to the elegance of biological neurons.
So, what is the takeaway here? If someone is looking at the AI landscape today, should they expect the GPU to stay on top forever?
Forever is a long time. In the short term, yes. The software moat is too deep, but in the long term, we are going to have to move toward more specialized hardware. We need chips that don't just do math faster, but chips that actually mimic the way the brain processes information, something called neuromorphic computing.
Neuromorphic. That sounds like something out of a science fiction movie.
It is closer than you think. People are working on chips that only fire when there is a change in data, just like your neurons. That would be way more efficient than a GPU, which is constantly running at full blast, even if nothing is happening.
See, that makes more sense to me. A chip that actually thinks, rather than just a chip that's really good at doing homework fast.
But again, the problem is the software. You can't just run a standard AI model on a neuromorphic chip. You have to reinvent the entire way we program computers. And right now, nobody wants to do that because the GPU-based models are working so well.
It's the classic trap. We're so good at the current way of doing things that we can't afford to try the better way.
Exactly. It's like being the world's best horse breeder right when the car is being invented. You're so good at making horses that you don't want to bother with those loud, smelly engines.
I think I'd prefer the horse. Honestly, they're quieter and they don't need a cooling plant.
Fair point. But for the listeners at home, the practical takeaway is this. The reason your technology is getting smarter and the reason companies like Nvidia are worth trillions is because we found a way to repurpose the hardware meant for games into the most powerful computational engine in history.
And if you're buying a laptop or a phone today, look for those NPU mentions. They might not be training the next big AI, but they are the reason your battery doesn't die in 20 minutes when you're using a filter on a video call.
Just don't expect them to help Jim with his potato salad anytime soon.
Definitely not. Well, I think that covers the basics of the AI hardware war. Thank you to Daniel for sending in that prompt. It's been a while since we really got to geek out on the silicon side of things.
It was a blast. If you have your own weird prompts, you know where to find us.
You can find My Weird Prompts on Spotify or visit us at our website, myweirdprompts.com. We have an RSS feed for subscribers and a contact form if you want to send us a question or a topic like Daniel did. We are also available on all major podcast platforms.
Until next time, I'm Herman Poppleberry.
And I'm Korn. Thanks for listening.
And remember, if your shoes start squeaking, you probably bought them from Larry.
Goodbye, everyone. Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts, as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.